Hi, I'm Angel and welcome to the video for CSM 61A, Week 4, Question 4, Collapse. So in this question, we are given this problem where we want to collapse the number. What does collapsing exactly mean though? Well, it means that if there are consecutive numbers, so take for example, these first two twos, well then we're going to collapse them into one number in our final product. So for example, we have 1, now this is the only ones we have 1, two twos, and because there's the same number, we'll go ahead and collapse it into one number, 2. 1, 3, we'll just move that down over there. 3 fours, well, they're all the same number, so we'll collapse them into 1, 4. And finally, a 1. Now, this kind of begs the question of, well, how do we even approach a question like this? Sure, we have this number of, we sure have this number for now, but our number can actually be a lot bigger and takes in any integer. So we can imagine something with 20 digits, and we wouldn't know how to approach it and make it solvable. So what could we use that would make a big problem solvable by breaking it down bit by bit? And the answer to that is recursion. Recursion works incredibly well for this because we don't know how many numbers there are, but we do know that we would want to modify based on a certain attribute, and then we can continue through moving the digits. So for example, maybe we want everything but the last digit, and then everything but that last digit, and then keep breaking it down, 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 down. All right, well, let's take a look. So here we're given this skeleton code. We're given define collapse, rest, n equals n, rest class equals n divided by floor divided by 10 and n mod 10. Okay. So first let's see what this n floor divided by 10 and n mod 10 is. Well, this is actually common in digit manipulation, where if we're given the number, let's say n were 1, 2, 3, 4. Well, then rest would be everything but that last digit. So it would be 1, 2, 3, 1, 2, 3. And last would be that last digit of 4. And this kind of applies for this is pretty common in digit manipulation questions because then we can isolate the last digit with n mod 10 because it'll give the remainder, i.e. the last digit of a number. And rest will give everything but that last digit if we use this 4 divided by 10 because we'll be saying, okay, just move it down one by one by one by one by one. All right. So now we know what rest and last are. So rest will be everything but that last digit, and last will be that last digit. So, okay, now we have the skeleton. Well, if we have an if statement, and then we have an else if statement, and we have an else statement. We're not given too much aside from that, so I'm kind of lost. Maybe we should look at the steps for how to solve recursion. Well, steps to recursion are basically this. First, we have to find a base case. So this is the smallest case we can possibly find, and the case that we can go ahead and say we know the answer to, so we can return. Then we have to make a recursive call on a smaller subproblem. So for example, maybe if n were a number, the next recursive call would be on n minus 1, and then n minus 1 again, n minus 1 again. Basically breaking it down into a smaller and smaller subproblem till we get to that base case that we can solve for sure. And finally, we process it, the result from the recursive call and combine it for final results, or combine it for final result. Okay, so it looks like that first step is a base case. So what could we use what could be a possible base case for this? What would we know the answer to for sure? Well, when do we want to stop actually continuing the problem? This is Oh, I know. We might want to stop continuing the problem when we run out of digits to consider. So here we see that we can probably use this rest value to kind of break it down into a smaller smaller, smaller kind of subproblem, because it'll turn into 1, 2, 3, 4 to 1, 2, 3, and then 1, 2, 3. The rest of 1, 2, 3 would be 1, 2, and the rest of 1 would be none. So we know that eventually we're probably going to break it down to where n is less than 10 or maybe even 0. So here you can take a few different approaches, but I'm going to go with, well, if I know that n is less than 10, then collapse would be 1 digit. So for example, if collapse were 2, I know that the result would be 2 because there are really no numbers left to collapse, and it'll just be the input. So we'll go ahead and say if n is less than 10, we can go ahead and return n. And here, this is our base case. We know that, okay, this is the smallest possible subproblem that we can consider, because if n is less than 10, we can go ahead and just push that through because there are no more numbers to collapse, and that we will always return n in this case scenario. Now, let's consider elif and else. Well, if we did our base, this could either mean that we have another base case, or maybe we have two types of recursive calls. What could it be? Do we think we have another base case to consider, or do we think that we have two types of recursive calls? Well, actually, I'm going to go with that we have two types of recursive calls, because here we have that it could either be that like the last two numbers are equal to the same value, so 4 and 4 might be the same, or the last two numbers are not equal to each other. 4 and 1 are not the same. So this kind of begs the question of, well, what would properly collapse these numbers? Or how would we properly collapse these numbers in these two different case scenarios? Would we want them to behave the same? Probably not. So in that case scenario, this kind of begs the question of, well, in that case, how do we know if the last two numbers are the same or different? And the answer to that is that we know that rest will give us everything but that last digit. So 1, 2, 3. And rest will give us everything but that last digit, and last will give us the last digit. So maybe we can use this to our advantage. Give you a moment to think about how we could make an elif case here. All right. So one way we could use an elif case is that, well, we could try to get the last digit of rest, and this will give us the second to last digit in our total number. And then we can compare this. We can then compare that with last and say if they're equal, well then the last two digits of the number, right, 3 and 4, are the same, or they're not. So maybe we can try to set up a comparison. So we know that we're going to use last. All right, that seems good to me. Since the last digit of the number is what we want to consider. And we know we want to check if they're equal to something of rest. So we'll go ahead and put rest here. But how do we get that last digit of rest? Oh, I know. Well, we actually get the last digit here, where we say n mod 10. But in this case, we wouldn't want to get the mod 10 of n, but rather the mod 10 of rest. And similarly to how n mod 10 gives us the last digit of n, rest mod 10 will give us the last digit of rest. So now we have the last number of n, or the last digit of n, and the second to last digit of n. So what do we want to do if they're equal? Well, actually, if they're equal, then we kind of works in our benefits to kind of skip over this number. So for example, let's say I take out this 1, and we start with that 4, 4, 4, 4. Well, 4, 4, 4, 4 would be the same thing as 4, 4, 4 because it would collapse. And that 4, 4, 4 would be the same as 4 because it would collapse. So in a way, we kind of want to skip those digits if it's the rest, if the last digits are the same. So how could we properly skip that digit to make a subproblem out of this? Is there something we could use? So we know we probably want to do a recursive call here. So we'll go ahead and have a return of some sort, and the recursive call itself collapse. But how could we make a subproblem that basically skips that last digit? Do we have a way to get everything but that last digit? And yeah, we do. We have that rest value. So we can go ahead and return collapse rest. All right, now we have finally this last case where let's say that these last two digits are not the same. How would we ensure that, hey, this last digit is included and we continue to the process for the rest of the digits? Well, it sounds to me like we're probably going to go ahead and have that, we're going to go ahead and have that recursive call somewhere. So let's go ahead and have a return statement because we're trying to return something. We'll have a collapse because that's the function we're going to do recursive call on. But what could be a subproblem? How would we break it down effectively to know that, hey, we're only, now that we've considered these last two digits, let's consider the next two digits, and the next two digits, and the next two digits. So if we want to get only the next two digits after that last digit, maybe we eliminate this last digit and we say, okay, let's continue on to these next two digits. And these next two digits become the last digit of the next one. In that case, maybe we should also return results. Our rest in that, we should also pass rest into that collapse function. Okay. Now, hey, that's kind of funny because now these two are the same. It's like I didn't even have this if case. And the answer to that is, well, unlike this, the case scenario before with 4, 4, 4, we want to go ahead and not skip this, but include it in our number. Because if we were just to have this, it would kind of continuously break down, but not actually add a value. It would just return whatever that last one is. So in this case, if we just had this, it would say, okay, let's consider the number after that, the number after that, the number after that, the number after that, and hey, now we have our base case. And it would just return 1. But that's not exactly what we want. So let's go ahead and move it back. Okay. So we want to include that last number now somehow. Oh, I know. What if we were just to try to add last? Would that work out? Well, the problem with that would be, let's say we have this number right here. Well, in this case, it would be, if we were to do a recursive call on this, it would skip this number. It would say, okay, 4 is the last digit. So we can go ahead and have 4 plus. We can move on to the next number. And we say, all right, 3 is different from 2. So we can go ahead and add 3. And then 2 is different from 1 here. So we'll go ahead and have 2. And 1 is different from here, or 2 here. So we'll have that. However, this isn't really what we want because now we're not getting this value, but the sum of the digits. So how can we get this value? How can we ensure that this last number will not modify the rest of the digits? Okay, what if we were to make sure that, hey, this place will not affect, or the rest of the places will not affect this one place. And we know that last digit we want at the end of the number because that's where it began. Oh, I know. What if we multiply this by 10 so that it will not modify this last place at all? Because if we were to multiply it by 10, well, then it'll be 40 or 4 plus 30. And then rather than it being plus 2, it would be plus 2 times 10 times 10, which is 200. And instead of that being plus 1, it will be times 10 times 10 times 10, which would be 1,000. And now we have a cool way to collapse our digits and leaving us with this solution. So yeah, hopefully this makes sense. If you have any other questions, feel free to ask them in the ed for CSM.